Hello, my name is Jay Shrestha, and I will be presenting my technical presentation for software design and documentation over a design pattern, specifically the servant design pattern. So without further ado, let's get into it. So we'll be breaking this into 5 different sections: a brief introduction, then we'll go over the structure, take a look at a UML diagram, look over the consequences, sort of what this benefits, but maybe some of the drawbacks will hinder your program. We'll go over the details of implementation, and finally wrap things up with looking at some sample code. So, very brief definition. What is the servant design pattern? This design pattern provides additional functionality to classes. Simple as that. Now, what does that exactly mean? Let's go over an example to flesh that out a bit. So let's say that you want to make a program that simulates traffic, and so you have these different classes of vehicles, like cars and trucks, but they don't have any sort of common parent. They don't have any vehicle superclass that they derive from. They're completely on their own. But they might have functionality that should be similar. For example, a car and a truck, they both drive. And they drive pretty similarly. At least for the sake of the simulation, they're pretty much identical. And so, you would technically write the same functions for both of these, but that would be obsolete. In this case, the servant design pattern would be useful. So let's look at the structure. Let's look at this UML diagram over here. So there's 4 main unique participants. There's the user, the servant, the serviceable interface, and the served. In this case, there's 2 of them. So the user is the client, a sort of main class. The servant and serviceable are the servant design pattern, the components of the servant design pattern, and the served are the classes that are being helped, being given additional functionality to. Think the car and the truck, served 1 and 2. So some of the consequences, well, the sort of brief definition or a brief statement, the servant design pattern will provide universal functionality to disjoint classes, classes with no common parent, but with the sort of additional interfaces and classes, some clutter that somewhat burdens your program. So to make this very simple, do's and don'ts: if you have disjoint classes, no parents, that should actually have similar features, this is great. This is a really solid design pattern to use. If your classes are already connected by inheritance, just make the functions in the superclass. It's a lot simpler. You avoid a lot of clutter of extra classes and whatnot. It's just easier. So more specific into the implementation, certain sort of key points that we should go over on using this properly. When you use a servant design, first you should know what you need. You should know sort of what is the universal functionality that I want to provide. For the example, for the simulation, I want the car and the truck to both be able to drive. Now we should sort of know what this servant entails. So it uses an interface to define what the servant does. We'll sort of see that in action. A couple points to use this effectively. We should be decoupling the client from the servant implementation. We just call this interface. If you remember back here, the interface is sort of the heart of this structure. Everything kind of connects to it. And we'll see exactly what that means. And independent, lastly. The servant shouldn't have dependencies of its own. We are having the served depend on it. It should not be the other way around. The servant should work pretty much on its own. So now let's look at sample code. Let's look at this in action. So first, let's look over the servant code using this design pattern. So there's 2 main things to look at. Let's look bottom up because that'll be easier. So this public interface drivable, this will be the interface for our served objects. So right now we just have some very simple core functions that all these classes will naturally have. So this car and this truck, for the sake of the simulation, they'll have a position And we should also be able to set that position, set a new position given a destination. Very simple. For the servant, you for simplicity, we'll just have this one function, this drive function, which will drive the object we care about. And so the main thing, if you look here, is we have this drivable parameter. This is sort of the implementation instance. That is the one of the core sort of parts of the servant code. And so, as you see in this class, if you see in this function, this method, this drive method is moving the drivable instance. It's setting the position to where it already is, plus a given distance. So now let's look at an example of the service code. So a simple car and truck class. Now main thing off the bat, as you see, they both implement this drivable interface from over here. And they both have that get position and set position methods. Very simple. They both have their own position, value, whatnot. And then they might also have their own functionality. The car might have passenger seats that you want to be able to open. The truck, maybe it doesn't, but it can load shipment. They each can have their own unique functions. And, maybe the truck can honk too or something. I don't know. You get the point. So now let's look at how this can all be used together cohesively. So this is sort of the client, the main function as I said before. So running through this, first you instantiate a instance of the servant, so this driver servant, this drivers. Then you make all the, you make the served instances, so the car and the truck, we have one instance each for this case. We can get the position at the beginning, they'll be 0 as per Java. But, the cool thing here is now we can move them, and instead of needing a drive function for both car and truck, two functions that would basically be the same thing, we can just have them be driven by the servant. You can kind of think of it like this driver servant. It's the servant. It's doing the action for the car and the truck. So the car and the truck. So as you see here, this drivers.drive for the car and the truck. The car, let's let it move 10. The truck isn't as fast. Let's just have it go 5. But, when you end up printing the new positions, they do change. The car moves 10, the truck is at 5. And this code, this all, if you were to copy and paste it and run it yourself, it will work. Trust me, you can check it yourself. And yeah, sort of the main takeaways here, as you can see, is we're able to get this driving functionality with just this one function in this one class. And, here, this is a pretty simple case. But you could sort of see how if you were to have a more complex program, this could be important. If you have, I guess if you wanted to make things more complicated and have acceleration, deceleration, stopping, get a lot more into the nitty-gritty, that's a lot of functions to have to write for both the class and the truck independently, whereas you could just throw them in this driver servant. The interface doesn't even need to be that much more complicated, but it all, works out. And so this is this is the true functionality of the servant design pattern. It lets you give, universal functionality to different classes, the car and the truck, as you see here. They implement the drivable, but they aren't children of any superclass. They are completely on their own, and they only really have the similarities of the classes of the methods from the interface. That's about it. And since it's an interface, technically they could have their own code. For the sake of simplicity, it doesn't. But yeah, you get the gist. And that's about it. I hope you've enjoyed this presentation. You better have. And yeah, these are the resources. And that is time. Thank you. Have a great day.